Hey everybody, Dr. Nelson here. Today I'm going to show you something called sampling. And sampling is a technique of collecting data to help make predictions. So what we're going to do is we're going to try to predict how many cars, vans, and buses pass through a very, very busy intersection in 1 hour. All right, check this out. All right, so here we are at a very, very busy intersection at a stoplight right by the entrance to the University of Rhode Island. All day long, there's cars constantly leaving the university and entering the university. Check it out. So today we're going to act like a traffic engineer would, and we're going to try to predict just how many cars or how many vehicles, including cars, trucks, and larger vehicles like buses, pass through this area in 1 hour time period. So what we're going to do is we're going to do something called sampling, and we're going to keep track of how many cars, trucks, and larger vehicles pass through this zone during a 6-minute span. All right, let's do that. All right, so what I did is I videotaped that area for 6 minutes, and then I went through the film and recorded just how many cars, trucks, and buses passed through that stop light over the span of 6 minutes. And here's the data. So altogether, there was 311 total vehicles, and of those 311, 280 were cars, 25 were trucks, and 6 were buses. All right, so now that we have our sample, let's go and do a deep dive into the numbers to see how we can make predictions. All right, welcome back. So let's take a minute to go over the data that we collected. So again, all together during the 6-minute span, there was a total of 311 vehicles. So I'm gonna write 311 over here. And of those 211 vehicles, 280 were cars. So I'm gonna write that as a fraction. So 280 over 311. And that ends up being around 90%. So about 90% of all the vehicles were cars. For trucks, we had 25 trucks out of the 311 vehicles altogether. And that's roughly about 8% of all the vehicles. And finally, that leaves us with the buses, right? And there was only 6 buses out of the 311 vehicles. And that is roughly about 2% of all the vehicles that went through the stoplight. All right, so now what we're going to do, we're not going to use something called a proportion, okay, to make a prediction. So what we know is that, again, 280 of the 311 vehicles were cars, and that happened during a 6-minute span. So all I want to do now is I want to write a proportion to solve for how many cars would go through there roughly during a 60-minute span. So remember, a proportion is when you have 2 equal ratios. So far I have 1 ratio of the data we collected. But what I want to do now is I want to write another ratio, another fraction, okay, that shows how many it would be in 60 minutes. Now notice to go from 6 minutes to 60 minutes, we need to multiply it by 10, right? So I'm going to do the same thing here to the numerator and denominator to get our new numbers. So if I multiply 311 by 10, that would give us 3,110 total vehicles. So one prediction we know already is that during an hour, over 3,000 cars would pass through that stoplight. But of those, if I multiply the 210 by 10, all right, so I'm going to do times 10, we can predict that roughly 2,800 of those vehicles would be cars. Let's now do the exact same thing for the trucks. So again, we know that during an hour, we'd have 3,110 total vehicles. And to go from 311 to 3,110, you can multiply by 10. So I'm going to multiply the 25 times 10. And 25 times 10 would be 250. So our prediction is during an hour, around 250 trucks would pass through that stoplight. And finally, we have the prediction for the number of buses that would go through that stoplight during an hour. So again, we had 6 out of 311 vehicles be buses, right? So this is our sample. So I'm going to write sample right here. And then using a proportion, right? We're going to predict that out of the 3,110 cars over an hour, okay, 60 of them would be buses. So that 60 is our prediction. So here's our official prediction. We're going to predict, based on our sample, that 2,800 cars, 250 trucks, and around 60 buses will pass through that stoplight during an hour, during the time that we collected the data. So sampling techniques are used across many careers and industries. And one really good example to talk about is Netflix. Netflix is really good at collecting data from the customers about what shows do they like and what shows do they not like. And they use those samples as really important tools to determine if they're going to make more shows or maybe end a show based on the data that they collect from their customers. So there's one more really important thing to know about sampling, okay? And that is, in order to get a really good representation of all the data, okay, you need to get different samples. So right now it's about 4 o'clock and it appears that the university just got out. So a lot of students are leaving the university. So right now the traffic level is high. If I came back here, say around an hour or two, my guess is traffic would be quite, limited compared to this now, all right? That's why a really important aspect of sampling is that you take multiple samples. Take samples at night, take samples in the morning, all right? That will really give you a true picture of just how many cars travel through that stoplight on a given day. So I hope this video showed you a little bit of just how sampling is used, not just to monitor how many cars go through an intersection, right? But how it's used in a variety of professions, all right? So what I want you to do now is I want you to try some of the problems that are coming up and then post the answers in the comments. All right, good luck.